I'd like to thank everybody for attending today. Our presenter is Brian Mora, who's one of our application engineers, and you couldn't be in better hands than his to give you a brief 1-hour overview of BIM and also a demo of Bentley architecture. This is one of a series of e-seminars that we've been conducting for our academic folks. And without further ado, I shall turn it over to Brian Mora.
Thank you, Laura. As far as the agenda today, what I'd like to do is first talk a little bit about BIM, give you a product overview, talk a little bit about MicroStation, Bentley architecture, some tools that are available for architects called Parametric Cell Studio. I'll briefly talk about generative components that will be highlighted in a later presentation, and also talk a little bit about SketchUp integration. If there's any product that I mentioned here today that you'd like to see a little bit more of, you hang on to the end of the presentation. So let's first start off with a working definition of BIM. Building information modeling is really how a team works together to design, build, and operate a building. It's really a process for project delivery. And it's about the right information to the right person at the right time, and data contributed to and shared by all project participants. That's the information management portion of the BIM acronym. And then finally, it's encouraging creativity, providing more feedback, and empowering a team. This helps leverage technology solutions through integrated design. Basically, the program, the design, the building, the operation, and decommissions the entire life cycle of the building. Contracts, specifications, budgets, drawings, and operational procedures. It's all about the information about the building and its life cycle. And finally, engineering analysis, construction sequencing, safety, and maintenance. It's defining and simulating the building and its delivery and operation. So you should be able to enjoy at least 10 of the top benefits that are available today for employing BIM. And that is save time by minimizing redundancy of information, creation, and management. Help reduce design errors through better building systems coordination. Optimize your project schedules through early identification of design issues. Improve quality through better understanding of design. Reduce misinterpretation through improved communication of design intent. And it's a lot more fun by focusing on the design and not the documentation or the software. You can help retain clients by efficiently delivering higher quality design and consulting services. And you can help expand services through the delivery of digital content for operations and maintenance. You can also meet requirements of client standards for electronic deliverables. You can also retain staff by providing professional growth, the current technologies, and project delivery methodology. So you may ask, why is BIM becoming so popular? And it's due to the fact that initially there was a report done by the National Institute of Science and Technology. They discovered that there was about $15.8 billion in cost per year in the U.S. due to fragmentation. And $1.2 billion was attributed directly to A&E firms, a 10% schedule reduction potential. So inefficient business process management costs total $2.6 billion. These areas here in which the greatest opportunities exist to reduce overhead labor charges with seamless electronic information management and exchange are document management, maintenance planning and management, information request processing, facility planning, and project management. Now, we're able to take care of all of those requirements because we operate on a shared platform. Bentley operates on 4 verticals sitting on top of MicroStation V8 XM Edition, which is our CAD engine. And we can also leverage the ability to do collaboration through ProjectWise. That's our AEC Content Manager. Each of the verticals of building, plant, civil, and geospatial have their own vertical applications that sit on top of MicroStation. We'll go into and focus on building. First, I do want to talk a little bit about the MicroStation V8 XM Edition. It's our flagship product for design, construction, and operation of the world's infrastructure. It allows you to do 3D modeling, import and export of DWG and DGN natively, standards for structured workflows and tools for consistent work, digital security for multi-level access, design history, which think of that as unlimited undo, complete revision control, and printing and plotting for multi-sheet, multi-format plotting and printing. Some of the highlights of MicroStation V8 XM Edition, especially benefits for a building user, are drawing production, structured workflows and content, design collaboration and review, and 3D modeling. We have an excellent graphic subsystem in this release that provides things like transparency, priority, gradient, true color, and Pantone color books. To give you a feel for priority and transparency, I'll give you a little demonstration here. We'll first start off in our MicroStation file and apply a different priority level. And as you can see, I can bury the text behind those shapes with color. This gives you greater control over the look and feel of your documentation. And then I can change the transparency levels so that I can bring to the forefront some of the contour lines, in this particular case, lot lines. Notice also that the dialog box for XM are transparent, and I can actually see through those dialog boxes. We also have an updated GUI where we do keyboard position mapping, cursor menus for easy numerical navigation, and refined tool sets. So it makes finding the tool that you need as simple as using your left hand on the keyboard and pressing combinations of keys rather than going and searching for a particular tool. For drawing production, we've introduced the ability to do PDF referencing. We can modify the handles in the PDF document. We can have multiple selections and attach that as a raster reference file. We've also introduced the concept of saved fences, almost like a saved view. Let's take a look at PDF referencing. In this example, I'll open up a MicroStation file, which is a border, and I want to attach to it directly. And I apologize for the resolution because we had to knock that down to 1024. Normally we run this at 1280. The raster preview window that you see here, I can actually attach that as a raster document into the border. And then now that I've got that attached, I can actually modify that PDF document to perhaps even make a red line comment here. So for example, if I select all those levels of annotation north and sections, turning those levels on, I'll go ahead and modify these PDF markings here on the left-hand side. I'll zoom in a little bit. I'll go ahead and move that marker using the regular MicroStation move command. We also have the ability to embed animations into our PDF documentation, and I'll actually show you that in the live demo. Also, we've improved drawing production by creating detailed symbols, fields, and model navigation. In the XM3 release that's coming out, we'll actually have a hyperlink that will take you from one drawing to the other. We do currently in the XM edition, through Project Explorer, have hyperlinks that are built into section markers and drawing markers. We also introduced structured workflows with element templates, workspace customization, task toolbars, and to enforce standards, the standards checker, which you can run against your entire project. The Project Explorer is for structured content, and this basically allows you to organize all of the documentation for a particular project, navigate through that project, and link those documents together through hyperlinks. We've also got design history where we can do plot differences, manage revisions and versions. We also have support for shared DGNs there. And of course, visualization is built into the core MicroStation product, and we leverage that through Bentley architecture and the other BIM applications. We can also do animation right in basic MicroStation, production, review, and schedule simulation. We provide, with our BIM solution, an interference manager engine that allows you to check for conflicts within the model. So you can take the structural, mechanical, electrical, and architectural models, review those with the ProjectWise Navigator, and resolve those conflicts before it ever goes out to the field. Also embedded with it is an animation producer that allows you to produce beautiful animations. Instead of bringing in a foam board for a presentation, you can create a PDF document that contains all of the design documentation as well as animation and visualization for rendering purposes. And you can also navigate and review through the model with ProjectWise Navigator. 3D modeling and mesh modeling, Boolean and mesh modify are new commands to the XM edition. And this also extends into Bentley architecture along with our Bentley site product to do terrain modeling and site preparation. And of course, we talk about AutoCAD interoperability. This allows you to import and export out to DWG and open up DWG files natively, as well as exporting and importing out to popular file formats such as Parasolids, VRML, Steel, STEP, ASYS, Q3D, and IGES, and also importing. Let's talk a little bit about design collaboration. From our 3D model, our intelligent 3D BIM model, as opposed to an unintelligent 3D or 2D design, we can then attach to that master model individual models from civil, structural, architectural, mechanical, electrical, plumbing, and interiors to create an intelligent 3D model, and from there create our extractions, create our plans and 2D elevations. This is true integrated multidisciplinary design. Bentley offers, through our BIM applications, any product that you need for your construction project, architectural, piping, HVAC, structural. You can also go out and generate all your visual reports, creating extractions to create plans and sections. This results in what we call coordinated documentation. In this example, one 3D drawing represented 3 2D documents. And the reason is that one recent project, for example, 16 3D details replaced 50 2D documents, saved 200 hours, approximately $20,000 in fees. Architects and engineers think in 3D. And the ability to design in a 3D BIM model and then from that create the 2D extraction, and also creating 3D documentation for the craft in the field who will direct the construction project, allows them to not have to basically flip back and forth between the elevation and plan to visualize what the construction sequence would be. So BIM takes it to a whole new level. And force change management, this is through design history. Think of design history as unlimited undo. Basically, I can keep versions of the drawing, get out of the file, and come back 3 weeks later and return the drawing back to its original state or any version thereof or revision thereof. I can also do a design compare showing the differences between the different revisions. Green would be things that were added or new. Blue is modified. Red is deleted. This is a high-level project that I worked on. John Portman Associates. These are the 2 twin towers over in Zhejiang, China. All done in BIM applications. Shots from the 3D design model here, and then the 2D plan reports that were generated from that, as well as some elevations. I also worked on a project that Claude up at the University of Maine, he's on the call today, the Orono Cultural and Arts Center, and I provided some support in a pilot project for that as well, so I was glad to talk to Claude today. I want to talk and focus on our complete BIM solution for building. The first one I want to talk about is Bentley architecture. And then, just as a side note, we do have Bentley Structural. RAM and STAT are the #1 and 2 design analysis packages for the construction industry. And those companies have been acquired by Bentley now. And they integrate through our Integrated Engineering Group, IEG, with Bentley Structural. So we also have made an acquisition of a company called Kiwi. And ProSteel detailing software just rounds out our complete structural detailing package. We also have Bentley Building Mechanical, which includes HVAC, piping, and plumbing, and Bentley Building Electrical Systems for lighting analysis and power, and also generative components. And then finally, Bentley Facilities, which at the end of a project, if the owner demands BIM, you could deliver to them an intelligent 3D model that they can use to manage their own facility. And a lot of architectural firms out there today are looking into extending their services to existing customers. So perhaps hosting a facility site to extend the capability of renovating and maintaining campuses and things of that nature. So let's focus on Bentley architecture today, talk a little bit about some of the top features. It supports what's called the 2D, 3D workflow. As educators today, not a lot of people may or may not feel comfortable drawing in 3D. Bentley architecture and other BIM applications allow you to work in 2D mode. Basically, in the background, a 3D model is actually being built, but their comfort level is satisfied working in 2D. Or they can work in a combination of 2D, 3D, or strictly over in 3D. Any one of these workflows work. They go from one to the other seamlessly. That's probably a highlight right there. Parametric editing, architectural relationships, and feature-based solid modeling and terrain modeling. All part of the core BIM solution. Curved walls, automated drawing production and coordination, data groups, which holds our catalog of doors, walls, and windows. Integrated schedules and reports are generated out of that intelligent 3D model. Smart spaces for interference analysis and integration. This enables 4D design, intuitive user interface, and powerful tools. Fully integrated rendering and visualization, animation capabilities, and you can also use any industry standards or easily customize your own. Let's take a look at working in the 2D, 3D choice here. I'll start off first working in a 2D plan. I'll switch to my 3D model, and then, for example, I would like to edit these 3 doors that I have in the wall. I'll first select that first door, and using the parametric values, change the door height and width dynamically, and then you can see that taking effect in the file itself. If I go back and do an element information on the second door, you can see all the parametric values for this particular door. Let's change the glass base height here. Go ahead and apply that. You can see that the window will change. So that's going from the 2D, 3D workflow there. And then we'll go ahead and render that. What I just showed you there is I synchronized the 3D model with the 2D model. And what sets us apart is the fact that we can synchronize those 2 models when it's convenient for you. You wouldn't necessarily want it to ripple through to all the other 2D design documents until you're ready to do that, because it could have unexpected results. Bentley architecture also has intelligent annotation through our data groups. So for example, any tag that you have for doors, walls, and windows, casework, spaces, they're all available and customizable. You can make it look like any kind of cell or block that you have today. I'll go ahead and just tag each one of these doors, and notice that because I'm using this particular cell, it would include both the ID number and the actual door width. And these are customizable, as well as the spaces, the intelligent space for the office. I can go into the data group here, and I can actually change values and apply that. So it is bidirectional, and in the XM3 release that's coming out, the other applications will all be bidirectional compliant.
Brian?
Yes.
Is there a setup process for synchronizing the 2D model and the 3D model in architecture, or is it automatic?
Yeah, what you do is you apply a seed file that allows this synchronization to take place. There's 4 seed files that are delivered with the product, and based on the workflow that you employ, you just simply merge the file in using a seed file. Once that seed file is applied, the workflow is seamless. And, I can show you that later. The other nice thing, beautiful thing about MicroStation and Bentley architecture, no third-party application required to do this type of visualization or animation. It's a single environment, and we use what's called a federated database. That simply means that you can break your project down into small pieces. I don't care how big the project is. Let's say a project over 25,000 square feet is a large project. I don't know if you agree with that, but let's just use that figure. What happens is, with a federated database, I can break that model down into individual components, such as structural, mechanical, electrical, and architectural. And then I can take it even further and break it down by floor, and maybe even by zone or component. And I could put as many colleagues onto that project as I can, and then using a master model referencing federated database approach, I can get that job done very quickly. And file sizes are very small. But visualization is part of extra benefit there. But the visualization capability, the material mapping that you see here, is all embedded within the 3D model with no extra effort on your part. Integrated visualization, some high-profile projects, Foster & Partners over in the UK, the Building Design Partnership, the Morphosis Federal Courthouse, TVS projects. These were all done using integrated visualization, but they also use generative components for true organic design. Some of the other examples of visualization, and again, I apologize for your resolution there, but if we were running at 1280, they would probably look a little bit better. All part of the product. I'd like to talk a little bit about Parametric Cell Studio. Basically what this is parametric modeling for cells. Some of the features for this is it has an inference engine, very powerful modeling tools. You can build in rules and relationships, constraints. You have rapid creation of parametric objects in integration with Bentley building applications. You can basically go out and build what I call a kit of parts. And you can build inter and intra relationship rules that are implicit or explicit. This includes things like constraints for geometry, 2D and 3D. There's many options here for building components, assemblies and geometric controls. Parametric design includes things for doors, windows, curtain walls, louvers, stairs, cabinetry. Let's take an example of a curtain wall. We could take this facade and apply what we call a path to the facade. From our kit of parts, basically cells, parametric cells on the left-hand side from the component section, I can drag these pieces out onto the facade. I can then click on the door, which exposes some rules. In the container view here, I can change and create some very simple formulas. So for example, I can take that 6-foot width and apply a formula called door width equals 6 feet. And then I can take the 5'10" dimension, and I'll use that width command minus the door width, so that always centers the door into the facade of the curtain wall. Now, no matter what happens to that width, if I change the width of the curtain wall, the door will always remain in the center of the curtain wall. Now what we do is we'll use this door as a path, go back to our component, and I'll drag out some other components, such as a panel, glass panel. Notice when I pull that out, there's 4 panes of glass to that particular part, and I can use the handles and drag it back to the door size and height. And notice it knocks it down to 3 panes of glass. I can continue this technique, aligning it using the parallel rule there, which is the double green line. So I have rules like parallelism, perpendicularity. You can see the perpendicular symbol there in the lower right-hand corner right there. Drag that out and put the windows over the top of the door. And I'll continue with this, putting in 2 more glass panels. You can see what's happening is it's building a relationship to that door. And 1 more last panel. And we'll size that in accordingly here. Build the relationship, drag that down. Okay. Now we've got our curtain wall basically built. Now at this point, I could take that entire path, change that 24-foot dimension to 30 feet, and we'll go in and add additional panes of glass. And think of the dynamics in your model that's taking place here. All the mullions, all the panes of glass, all the casework, everything expanding correctly and changing within your model. And because of the rules that are built in there, you're able to have a lot more control and very quickly change the design. This building over in the UK was done doing generative components. It's also using green building design, natural ventilation. I want to talk a little bit about SketchUp integration. One product that is really being employed by architects today is Google SketchUp. It was acquired by Google. There is a series of 3D warehouse models that are available. If you ever go up to Google, go to 3D warehouse and look for anything out there that you could think of. Chairs, buildings, scenery, actors. Let me show you the first use of SketchUp integration for the architect with Bentley Architecture. Say, for example, I'm working on a hospital project. I'm going to open up a hospital suite for a renovation project for a hospital. This is a typical hospital suite. Now I want to take it to the next level. There's some limitations in Google SketchUp, and I can't do that. So I want to bring it into Bentley Architecture. Notice we have a new SKP file, and also right above that, 3D Studio. I can open up that SketchUp file natively with MicroStation in Bentley Architecture. Matter of fact, I think it even looks better in MicroStation or Architecture. And then I can save that SketchUp file off, either as a DGN or DWG, to save and give that to my colleagues to work on so that they can further explore that with the advanced capabilities that are built into MicroStation. You can also use SketchUp files as references. In this example, I'll open up an existing building that I designed with Bentley Architecture. And I want to show the owner this building in reference to the city skyline of the city of Philadelphia. I went out to the Google 3D warehouse, found a SketchUp file for the city of Philadelphia, and you can also geospatially locate this building out in Google if you've ever gone out and Googled your house to spatially locate that or find it. And then what I'll do is I'll take this to the next level and I'll render that so I can do a solar analysis and show the owner the building in context to the landscape. And lastly, what I want to do is show you placing a SketchUp file directly in a MicroStation file. Say I'm working on an architectural project. I can go up to the Utilities pull-down. There's a new 3D warehouse pull-down there. Go out to Google, search the 3D warehouse for chairs. I'd like to go out and find a nice Craftsman-style chair. I'll go through the Google 3D warehouse here. Just unbelievable the amount of information that's up there. I'll take that Google SketchUp model, I'll bring it directly into MicroStation. But to make this even better is when we render this, you see the material mappings for the wood and the leather in the upper right-hand corner. Looks great on my screen. I know you maybe see a little stuff on your screen there, but works great.
Brian, do those SKP files come in as solids so they can be modified in MicroStation?
Yes, they do, and I actually have an example. Is that Claude?
That is.
Claude, I did a little example at the B conference this year. I'm going to be teaching a Bentley Facilities class, and I actually used that chair. When I brought it in, I wanted to create a detailed, sparse, and 3D view of that chair that could be expressed in the facilities object database. Took that solid and was able to create, I've got a rendered 3D view, and then I've broken it down to its basic component geometry so I could have like a nice top view. So yeah, you can absolutely do that.
Good.
What I'd like to do for you now is I'm going to go into a virtual machine that I have, and this is where I run all of my building applications. MicroStation is the CAD platform. Triform is the 3D modeling engine that Bentley Architecture, Structural, Mechanical, and Electrical run on. And as I mentioned before, Structural, RAM, and STAD all work seamlessly. You can round trip the data between RAM and STAD models. You can start your model in RAM or STAD, bring it into Structural, round trip that data, and do analysis all day long. You can run those 4 applications as a suite. That means that you don't have to jump in and out of each application. One launching into the building suite icon gives you access to all of those tools. for those different disciplines. Bentley Navigator is the tool that you can use to review the 3D model and check for interferences, interference detection, do walkthroughs, animations, and schedule simulations, tying it directly to Microsoft Project or Primavera Project Planner. I'm also utilizing ProjectWise Explorer for the collaboration piece. Now, I'll mention to you that all of these tools that you see here today run totally independent of one another. But in a true multidisciplinary environment, all of these tools enhance one another. So at no point in time do I want you to walk away saying, oh, I need ProjectWise, I need structural. You don't. You can use any one of these vertical applications independent of one another to do a BIM project. Now, I simply use ProjectWise Explorer to store all the documentation that I have for all the projects that I'm currently working on. In this case, we're going to work on a marketplace project, and I also have their electrical, mechanical, and structural. I've got this file currently checked out to me. I can see that by scrolling over that it's checked out to me, the administrator. What's nice about ProjectWise Explorer, just mentioning it to you briefly, is that if you're working on a project and you've got multiple colleagues working on that project, you would be able to see at any point in time who's working on what drawing, when did they work on it, the entire life cycle of that document. Now I'll go ahead and open up that file here, and now we're in Bentley Architecture. We're working on a small marketplace building. This administration area contains offices and bathrooms, as well as a gallery. And then this larger marketplace area is where the vendors have their kiosks where they sell their wares. Let's first start off pointing out to you the new task-based modeling menus on the left-hand side where things are logically ordered, such as floors, ceilings, site, structure, advanced modeling features for Triforma, the drawing manager for extraction, floor manager for controlling elevation and floor selection, basic microstation manipulation, rendering and animation, schedules and reports, and sheet annotation for final documentation and creation. So everything is located right at your fingertips. No more filling up the screen with millions of menus, all organized very efficiently. Let's first start off. I want to walk you through the process that an architect may employ so you kind of get a feeling for the tool. Let's start off by doing some just raw massing here. I use some of my really nice 3D modeling tools to perhaps cut through this shape using this green shape. And if I select this, we take a look at it, you can see that nice slice through the building. We can then copy that feature, and we'll copy that feature, say, 3 times here. And then when I click on it, you'll notice that it exposes the feature cut. That could be a repetitive feature cut. I can go ahead and put that in, and that does a very nice job for our schematic design mass modeling here. Now to emulate the barrel vaults, I'm going to go ahead and put, say for example, a 12-foot radius on here. I'll go ahead and select this first bay and apply a radius to it, and then work my way down each bay until finally I get that 3rd bay there. Okay, and now if I maximize that view, I go ahead and rotate that around. You can see very nicely the office space with the hidden lines showing there, and I get a very nice idea for my mass modeling. Now, based on an interview that I did with the owner, we have some very nice intelligent space tools. Say we met with the owner and we sort of sketched out informally on a piece of paper over lunch the program areas for this particular project. We sort of sketched those out here, and I've superimposed that raster image over my vector file here so that I can get a better idea of how this is going to work. For example, if I zoom in to this area here, and I first want to show you under Schedules and Reports the power of the data group. The data group basically allows me to go out and keep track of anything that gets placed into the file. Doors, windows, walls, handrails, spaces. And currently right now I have only established the tenant, gallery, studio, conference, restroom, and lobby areas of this particular building. And I've gone ahead and put those intelligent spaces into the file. As a result, it gives me the perimeter, the program area, and the actual area based on that intelligent shape. So if I come back to floors and I go ahead and create space here, you'll see that the first thing I want to do is I want to create an intelligent space for the administration area. And I've already predefined these in the data set, so it's a little easy to do here. I'm going to come over and grab that. And you watch as I place my mouse into the file, it's automatically incrementing, creating both the program and the actual area. If I come in and add the mechanical room to this, put that into the file. And then I'm going to employ some very sloppy drafting techniques to get this point across. I'll go ahead and place multi-sided shapes, the storage area. And I'm purposely going to bring it way out there and then place that right there. And you can watch as I modify that corner, what's the values inside of that box. I use a origin command here. Lock that in with AccuDraw. And you'll see that change dynamically. We can also use these smart spaces to extrude walls. And then as I move walls around, the spaces, the intelligent spaces, changes with it. If I go back to my scheduled reports now and check my data group and look at the spaces are in there automatically. The new one, admin, mechanical, and storage. And if I scroll over, you can see that it added the program area and the actual area. You can see here, through the data group, I'm able to place and create my space schedule. But I can also create a very formal-looking report in addition to that. So let's compare. I can create at any point in time while the model is being built a very nice looking space, door, wall, and window schedule. Anything you want comes out of that data group. And it's dynamic. And it updates dynamically. Bentley structural and mechanical right now, that's bidirectional. That means if I make a change in the spreadsheet, that spreadsheet will drive the change to the model and all the associated documentation. Bentley architecture will follow with that in the XM3 release. Let's use an existing 2D floor plan. This will show you how you can very quickly take an existing 2D drawing that you might have, either from a vendor or contractor, and you can very quickly build a 3D model from that. And in this example, if I set my view here, you can come in and see a very nice compound wall assembly that I built from this. Zoom in here and just scroll around a little bit. You can see the profile of that wall very nicely. If I put my compound switch back on, let's just go take a look at how that was built. I mentioned the data set and the data groups. This is our logical method for organizing all of the components that go into your project. And it's very easy to create new properties. This represents all of the different components from our family of parts that produce that wall in section here, including air spaces. So you can see I can pull from a list of family and parts and then apply an offset of height, vertical offset thickness to come up with this composite wall. Very powerful tools. And by the way, all of the rendering techniques that I showed you earlier are, of course, embedded within the properties of that wall. So for example, if I went to a C1010 here, which is like my interior walls, you can see all the definitions are built right into the product. I can hard code in the heights of particular wall types, as well as their true thicknesses. And I can put their rendering properties along with their material that gets mapped to the surface. So if I wanted to show that wall as brick or wallpaper or paint, I can plug that in here.
Brian, when you import a drawing from somebody else, a floor plan, and you want to extrude it into a three-dimensional model, do those, like exterior wall lines, need to be connected as shapes?
There's a tool here called Separate Forms. Now, if the footprint of that floor in the other file was one contiguous smart line or polyline, and I want to have the ability to extrude that, I could go around, and if it was all one unit, I could select all of it and it would extrude it all. I could give it the ability through the separate form switch to actually move an individual component of the wall instead of the entire wall. Say, for example, this section here, if I wanted to just pull this wall section out, not the entire wall, the separate form switch allows me to do individual wall components. So you have a lot of flexibility. It doesn't matter if it's a DWG file or a DGN file, I can utilize it. Basically, two methods, okay? A contiguous polyline or smart line versus individual line segments. And then by that I mean I have to click on each individual line and it would extrude that line up. Then I would go back and I would use this tool here, my wall cleanup tools. And my wall cleanup tools would then allow me to go around and make and connect those individual wall sections together. And that would turn it into a much more intelligent wall. But it sure beats drawing it from scratch.
Somebody sent me a drawing that just had, and I just used, say, the interior wall line as a shape, and I told it was a 12-inch wall thickness. I could just extrude that single line shape up into the wall height, right?
Yes.
Okay.
Yep, exactly. When I place a wall or I extrude a wall, I can do it by the part definition. If I turn that switch off, the data group for this 1 hour rated 6-inch CME block wall, its default height is 12 feet. But I can override that and put it in at whatever height that I want. But I want to ensure standardization, so I want to use the by part definition so that when users are drawing, in this case, you see I'm working in the 2D mode. I'm working in a 2D plan. So in this case, I could go ahead and place into the file this wall. Now, if I zoom in on that, just kind of walking you through some of the steps that you typically would do. I just use a regular old MicroStation copy command. I'll go ahead and copy this up, say, for example, 6 feet. And now I'll show you some of that wall cleanup tools that I was talking about. For example, I'll make a T-joint out of this. And notice the wall cleanup is very nice here. And then we can also do things like build composite walls. I can put some furring in here. So if I select the side of this wall here, put some furring on that. Now I've got furring in there. Then I can go back and use that same tool. Only this time I'll do a bisector of that. I'll select that wall, working my way around. What this did, this put some furring and some sheetrock up approximately 12 feet, put one more wall in here, my center placement. And I'll lock that in. And now let's go ahead and place a couple doors in there so you can kind of get a feeling of the door tool. This brings up the door tool. So for example, I have a whole catalog that I can scroll through here, fancy doors. I'll put some French doors in. And I can control the placement of that using ActiDraw. And I might also want to go ahead and put in some single flush panel doors down here in these lower rooms. And notice as I move my mouse around dynamically, I can control the side of the wall, and the door swing, the handle, the location. Okay. Now, I also have the ability in this XM release to just right-click, press, and that exposes all of the tools that are available for that particular object. Notice I did not have to go searching, even in the task-based menu, as well as it is organized. I now have access to the ability to change the door swing, or I can even use the handles here to flip the door swing, such as that. I can also change the parametric properties of that and modify it. modify the hand direction. And I can also do that with a handle, just pulling the door, like so. We also have very nice schematic casework. So for example, I'll put in both a backsplash and a countertop here. Go ahead and lock that in with AccuDraw. Okay. So now what I want to do is I'm going to switch back over to my 3D plan so that you can see the 3D model that got built in the background. See this schematic casework, even with some material mapping on it. You can see some wood grain on there. Okay. And then I can change this to a top view here. I'll fit that. And because we've built a relationship into our wall, for example, I wanted to take that wall, move it out, say 5 feet. That's got to do with the locks. Turn our graphic group lock on now, and move it out 5 feet. See, I can control the whole model that way. That's a compound wall assembly. That means it's got some exterior work, maybe some brick on the facade. You can even do things like perhaps even rotate this around, say 10 degrees here. So I'll pick that wall and pick that corner right there. This will clean this up very nicely. I go back to the 3D model.
Brian, what defines the wall as a graphic group?
Okay, good question. See right here, composite walls. We have this ability to create what's called a composite wall. That means the interior portion of this could be a CMU block wall. The exterior of this could be a brick wall assembly. And the interior could be furring for sheetrock and stud. And I can apply and basically sandwich in any type of wall type to build this wall assembly. The graphic group lock, what it does is it allows the whole wall to work as one unit. I can disable the graphic group lock and move individual wall assembly pieces independent of one another. Now what I'm going to do is go back to the plan here. So I'm going to go to my drawing extraction manager. Go to the model file here. The extraction manager allows you to set up extraction definitions for plans and elevations. When I click on this tool, you'll see in the file, it's cutting a section looking through the model at some predetermined height and width. And what I'm doing now is, by opening that extraction that has been previously processed, I'm getting asked, the drawing is out of date. Do you want to synchronize with the model? This is the 2D, 3D work choice that I was talking about. Let's say on a very large project, I may not want to synchronize the model right now because I'm still doing design exploration. But in this particular case, I'll exercise my option and say yes. What this is going to do now is take all of the changes that I just made, added the rooms, the doors, rotating the wall. It's going to go ahead and add that in. Now let's go ahead and take it to the next level, which is creating some design documentation. I'll go ahead and just put a fence around this. By the way, I could go in here and annotate this now, and I'm going to go ahead and create a print. Built within MicroStation, XM Edition, and Bentley Architecture is the ability to go out and utilize a PDF plot driver that is built with this. This allows you to do things, create 3D PDF documentation, full text searches. I'll go ahead and create my print here because I'm using a managed environment here. I'm going to go ahead and plot that.
I have a question.
Yeah, go ahead.
When you were working on the 2D, 3D choice back there, when you were on the 2D, was that the master, was that the extraction itself embedded inside the file through the models down there?
Exactly. Exactly.
Can you please kind of like walk us through of how you set that up?
Sure. Let me just kick this off. Okay, I'm going to put this into the Marketplace folder in Architecture here, and go ahead and save that while that's processing. Sir, what was the question again? I'm sorry.
Yeah, well, I noticed when you were working from 2D to 3D on the bridge there,
yeah.
When you were working on the 2D, that seemed to be, is that the extraction floor plan itself? Because it looks like a sheet file there.
I see what you're saying. No, that's an excellent question. This is the 2D representation of the 3D model. This 2D sheet model works with the 3D model, I can go back and forth as I please. I could make a change in the 3D model.
Now, you're saying it's a two-way street, so it doesn't matter whether you make a change in the 3D model or the 2D is going to update either one?
Yeah. Yeah.
But how do you set it up that way? That was my question.
Okay. Just for example, file new. Okay. Do you see this seed file?
Okay.
ATF plan and model two-way.
Mm-hmm. That comes with the package, right?
Yes. This comes with the Bentley architecture. And any of the 3D modeling vertical applications. Delivered with the product is a series of seed files. There's 4 of them. ATF plan and model 2A, ATF plan only, 3D in the ATF. That's it, 2D.
Okay.
So all you need to do what I just showed you, is use this seed file, ATF plan and model 2A. When you start a brand new drawing. And then that gives you the ability to work in the sheet model in 2D mode or go over to the 3D model and make a change within the 3D model itself.
So I have to work over that seed file.
You use that seed file to start your new drawing.
Let's say we have a lot of configuration done to a seed file, but then we need to use this other seed file. And we would lose, like, for example, levels or things like that were on the other seed file.
No, you wouldn't. Because we utilize what's called a dgen lib file, a dgen lib. And all of those seed files point to that dgen lib and pull the levels from that. And the workspace that you're using, that's all configured.
Okay.
I want to show you and take PDF creation to the next level. So basically, show you some capabilities. This is a PDF that we created for a project down in South Beach in Miami. Again, mentioning the fact that you don't have to take storyboards into review sessions with you. I can embed things like save views. I can put that into the documentation. I can come in and start actually going into the building here. I can go in and walk into the project inside the PDF document. Looking around. I can also embed animations. I can start this from any point of view from within the file. Notice this car turning around here. That's just one example. Taking it to the next level, let's do construction sequences. I can fully embed all the design documentation as well as providing different illustration techniques like transparent or shaded. I can then go in and change my views so I can see this more clearly. I can then go in and take a look at the tank insertion here for this construction crane sequence. And again, this is all right out of just basic Bentley architecture and MicroStation. And then I can go in and do a tank insertion close-up here to watch the tank come in.
I'd also like to point out, by the way, for all of you that live, this is all very smooth. It's just via the internet that's making it a little skippy.
Little skippy because of the live meeting. Now, let's talk a little bit about design documentation. I showed you out of Bentley architecture how I could print just one sheet and create a PDF. But I can also batch print and create multi-sheet documentation, including sheets of different sizes, A-size sheets and B-size sheets. And as part of just the creation of hitting that print button, I was able to go out and create this PDF document, including an index sheet that has embedded hyperlinks into it that would drive me to other drawings. So for example, I could come to my plan and profile sheet, zoom in on this detail, click on this hyperlink that was embedded, and as a result of just hitting the print button, it extracted all of this intelligent information into the file. I can come out and do things like full text search retrieval inside of my PDF. When I want to go out and do a search, utilizing search tools, I can go out and find every instance of the word adjusting ring. This will search all of the documents within this PDF file. Clicking on the hyperlink here will drive me to that particular associated piece of documentation. In this case, brings me to the manhole adjusting ring specification sheet. So So there's no limit to what you can do in creating this document set. It's portable. And what is the most prevalent digital media that's out there today? It's Adobe, and everybody's got a copy of Adobe Reader, which is free. And you can create this documentation for them for free. At this point, I'd like to jump back out and finish up my presentation. Show you some of the other capabilities here. I think this is pretty sweet. Let's do an array. This is a utility that allows you to create a facade with an array of windows. So for example, I'll array along this path and choose from my catalog, say, a fixed window. And we'll space this out accordingly at some specific, maybe 3 feet above the grade. Go ahead and place that fixed window into the array. Place it. And then using just regular handles, drag the windows over dynamically. Notice I'm just doing a right click there and it exposes all of the tools that are available for this particular object. I can go ahead and size this accordingly, dynamically.
Where did that tool come from?
Oh, this is built into Bentley architecture and based MicroStation.
How do you invoke that tool?
It's an array tool that is available in the XM edition.
I know, but how do you invoke it? I didn't see where it came from.
It's actually an advanced modeling tool. If you look at the left-hand side of the task menu there, and you can basically build any kind of template using the template tool. So this was I've already had this element template built, and now I'm just applying it to the facade. You can build different types of element templates that do different things for different projects. And then in this case, I want to take that flat facade and have it modify itself to an arc to make an arced wall. Like that with it. Here's another type of an array. Who asked that question?
Oh, this was Al.
Al. Okay, look right there. Edit template. The element array tool that you're looking at right here is from the element template along the top left-hand corner of my screen. That little pull down that you see up there in the upper left-hand corner next to A floor, and right there is where the element templates are created. The things that you might want to do with a template, for example here, I've got a civil project, and I want to edit the array and change spacing definition here so that it will add more light. So these are just some of the things that you can do with element templates. And it's good for standardization as well. Just kind of point out a couple differentiators here that I think are really important that sets Bentley apart from other applications that are out there today. Bentley uses what I mentioned, federated database approach versus a monolithic database, so the file sizes are small, workloads are manageable. We also support industry standards such as IFCs, which is Industry Foundation Classes. At a basic minimum, all CAD applications should adhere to basic IFC requirements. That's some semblance of intelligence that's applied to a door, a wall, or a window. And we are IFC 2x3 compliant. We also have the ability, as I mentioned, to produce PDF, rendering and animation, schedule simulation, and interference detection. It handles any size project. I think this sets us apart from other applications that are out there. We've used this on huge projects like GM factories, high-rises, the Pentagon project, with no degradation in production or performance. You can share project models and information between multiple offices utilizing ProjectWise as I showed you, and the 2D, 3D choice that I showed you. Also, full suite of integrated products, architectural, structural, plumbing, electrical, site tools, parametric tools, Cell Studio, and generative components. 2D views are synchronized with the model on demand, which means the model runs faster on large projects. Its standards are enforced through data groups, MicroStation, and ProjectWise. Therefore, methodology and output are very flexible. All the linking to the documentation and hyperlinks are fully functional, and the data management controls are controlled through the network installation. Well, talk a little bit about professional services and BIM consulting. I belong to a group of people who will come out on site train you, install it, configure it, provide project-wide solution design and implementation, project coaching to ensure success on your projects, visualization, consulting, integration. We've got over 300 professional service staff. We have the Bentley Institute. This means that you can take training in various methods such as e-learning through Illuminate sessions. Those are 4-hour classes that run between the hours of 11 o'clock and 3 o'clock Eastern Standard Time. You sit at your desk with a headphone and microphone, an instructor like myself, and you can work 4 hours and then train for 4 hours. We also do on-site training, or you can come to any one of our facilities. We also have a mobile lab that can be shipped directly to your facility for training purposes. And we also support the B Careers Network with over 400 institutions of higher learning across the U.S. alone and 700 schools around the world. And those numbers are growing, and I'm hoping that some of the educators here today...
900.
900? Okay. So you see that? So it's changing. Just 200 alone have been added in the several weeks since I put this slide together.
I'm very busy.
So, Laura, I'm going to turn this back over to you. I thank you all for your time and open it up to any questions and answers that you might have. I know, Claude, you might want to stick around for the facilities.
Okay, really quickly, I'd like to reinforce what Brian just said, and thank you all for taking time out of your busy schedules to attend our BIM seminar today. Many thanks to Brian Mora for a great overview. It's a very rich subject area with lots of ground to cover. I think he did a fantastic job. As you all know, BIM is not just a buzzword anymore. Its time has arrived, and it is the world your architecture students will be entering upon graduation. Please keep in mind that Bentley's academic subscription program, to which most of you do subscribe already, includes MicroStation, Bentley Architecture, Triforma, Bentley Structural, Bentley Building Mechanical Systems, and the structural analysis products StatPro and RAM Structural System. Very soon, upon its commercial release, generative components will be included as long as you've had training. And this solution, which you got a great sneak peek of, is already being used for production by Foster & Partners, Morphosis, Shop Architects in New York, KPF, and etc. And it was recently showcased, as it is every year, at the Smart Geometry Conference in New York, which Brian mentioned, that happened this past month. If you'd like more information on Bentley's BIM solutions or generative components, please send me an email at laura.meier@bentley.com. And with that, I will ask if there are any more remaining questions.
Can you please repeat your email, please?
Sure. Laura, LAURA.Meier, M as in Michael, EIER, @bentley.com.